So today is the 20th day of the 30-day LeetCode challenge, and the problem is quite simple to understand. Construct binary search tree from Preorder Traversal. So the problem is we are given a result of a binary search tree Preorder Traversal, and we are asked to reconstruct from it. For example, in this one, the reconstructed tree should be like this. Okay, so how do we solve it? The tree is a recursively defined structure. So in the most case of the tree problem, if not too hard, then we will solve that problem in the recursive way, mostly. So the idea in this is like in the pseudocode here. As you can see, we first pass the index. The index is where we are now in the array. So index first is 0. And we first check if the index is greater than or equal to the size of v, where v is this one, 8517 10 12, which is the vector of the preorder traversal. So if the index is out of bound, then we simply return null. Why we return null? Because this symbolizes we have reached the end of the node construction. And then we will get the value according to where the index lies in the vector, which is here. And the most important part is we will set a min and max, which is the lower bound and upper bound for the subtree to construct. Why? Because in the binary search tree, because in BST, all the value in left subtree should be less than the value of root, and all the value in the right subtree should be greater than the value of root. Suppose we did not have the duplicated value in binary search tree. So when we constructed the subtree, the node of a subtree, the value should lies in the bound, or simply say B. And if the value is not in bound, then we simply return null, because there could be such node which violates the rule. And if all the check pass, then the index will be incremented. And then we recursively construct for the whole binary search tree as here. And if we construct the left subtree, then the current value of the node will be the upper bound. For the left subtree. And for the right subtree, because all the value in the right subtree are greater than the root, so the current value will simply become the lower bound, which is the blue one for the right subtree, and their upper bound still will not be changed. Sorry, I will rewrite here, which is the upper bound will become value in the left subtree, and the lower bound will become value as well, so for the right subtree, but for the respective min and the max value will not be changed. So that's how we construct the tree. Okay, now I will run through the example to understand how these work. The first is if the current node is 8, then the 8 is the root. and the 8 is now in the recursion call state. Clean a bit. The 8 is now in the recursion call state. Then, as we go, the 8 will call the left call to construct the left subtree, which will be pushed to 8L, and the max value of the left subtree will be updated, which is 8, and min will still be int min, and index, because the current value will be incremented to 5. Oh, sorry, the index will be incremented to 1, and the index become 1, and since the index is 1, and the value is 5 for the value in the preorder traversal. So this is legal. So 5 will be constructed, and after 5 will be constructed, we'll call 5L, and the max will the upper bound of the left subtree will be updated. However, the min does not, and the index will be still increased because in before the 5 is a legal value in the, because the 5 is legal value at here, so the index will be incremented. So index become 2, and the value is 1. So 1 will call left, but nothing in the left of 1. However, the index is 3, and max will be 1. But here we have the problem, because since index is 3, but when index becomes 3, the value is 7. Okay, the value is 7. And 7 does not lies in the interval. So when 1 calls left, they simply will return null, the null node for 1, which 1 will eventually become leaf, because the same is true for the 1's right. Okay. And then will be pop out from the stack. And then the value after that, 5 will call right, since it's recursion function, and since 5 calls right, we will change the lower bound for the right subtree, where min is 5, m is integer max. Oh, sorry, m is 8. And the index is 3. So at 7, it is okay to construct. And in the situation of 7 will call 7 left and 7 right, but this one is simply the same as this situation. So we will get a leaf node for 7. Okay. And then 5 will be pop out for the recursion call. So that's the 8 left, because 5 will return a value to 8, and the left of 8 node will be connected to 5, which finish the left part. And the same is true for right part, so I will just do more quickly. Max. Then it becomes 4. So 10 will be constructed, and 10R, 12 will be constructed, and then 12 left, 12R, because 10R is nothing, so 10 left is nothing, so I did not write, but simply is 10 left, but here is nothing. So return nothing, return, and finally 8 right is connected to 10. The subtree here and the subtree here is fully constructed. So all of them will be pop out, and finally 8 will be pop out. So we finish all the recursion. Okay, so let's code it. So we create a helper function to create a node, and the value we need is the upper bound for the node subtree and the lower bound min, and vector of preorder simplified as p. And if index is out of bound, then we simply return a null node. Or the value, which is PIDX, and if value greater than the max or lower than the min, return null. And if we pass all the check, then we increment the index to get the next value for create. Connected to the left node. And here for the right, and simply return the new node after we constructed this one. Max will be initialized at int max, so will the min to be initialized at int min, and p is here. So let's see if this works. Okay, that's for today, and thank you for watching.